So we're going to run through solving this system using the method of elimination. I specifically picked a problem where the coefficients here aren't so nice to where you can just multiply one equation by a pretty integer and get everything to line up. So instead, we're going to multiply both equations by some integer to get them to line up. So I'm going to go ahead and eliminate my x's. To do that, I'm going to go ahead and multiply the first equation by 3. The second equation, I'm going to multiply by 4. Notice I'm basically just choosing the coefficients of each x. And I'm going to rewrite the new system. So when I multiply the first equation by 3, I end up getting 12x minus 15y is equal to 60. And for the second equation, I end up getting 12x minus 12y is equal to 16. And now here you can see that these 12x's are lined up perfectly, so I can go ahead and subtract the equations. So the 12x and 12x cancel. We end up having negative 15y plus 12y, because I'm subtracting a negative. So I get negative 3y is equal to, we have 60 minus 16, which gives us 44. Then we can just divide out by our negative 3, and we get y is equal to negative 44 thirds. If you wanted to, you could take this y and plug it into one of the original equations, whichever one you want, and then solve for x that way. I'm going to go ahead and just do elimination again, but on the y's this time. So let me move this work over. Okay, so in the yellow here, this was me eliminating x. To eliminate y, I'm going to go ahead and multiply the first equation by 3, and I'm going to multiply the second equation by 5, and this is going to eliminate, or it's going to set me up to eliminate my y. So when I do that, I end up getting 12x minus 15y equals 60 again for the first equation. And the second equation, when I multiply by 5, I end up getting 15x minus 15y is equal to 20. And now these are set up to where my y's are aligned really nicely, and I can go ahead and subtract the equations. So when I do 12x minus 15x, that gives me a negative 3x. When I do negative 15y minus a negative 15y, those cancel. And then I have 60 minus 20 gives me 40. So when I divide out by a negative 3, I get x is equal to negative 40 thirds. And so here I have my x and y coordinates for my solution. So basically, the original two equations, they're linear equations. If I graphed them, the intersection point would happen at negative 40 thirds, comma negative 44 thirds. And that would be our solution.